What is dimension of physical quantities? Question mark. Explain by using suitable example. Any physical quantity can be represented by using dimension. Any physical quantity can be represented as combination of seven base fundamental quantity. Its symbol are as follow: mass m, length L, time T, electric current ampere, thermodynamic temperature K, luminous flux CD, and quantity of matter mole. All M, L, T, A, K, C, D mole are written in bracket. Dimension power or exponent to which base quantity is raised to is called dimension of that quantity. For example, volume is equal to L cross B cross H is equal to meter cross meter cross meter is equal to meter cube is equal to L cube. Dimensional of the formula of volume is in bracket m0 L cube T0 bracket over. In volume, dimension of length is 3 where dimension of mass and time is 0. For example, force F is equal to ma is equal to mass into acceleration is equal to in bracket m1 bracket over into another bracket l1 t raised to minus 2 bracket over is equal to in bracket m1 l1 t minus 2 bracket over. In force, dimension of mass, length and time is 1, 1 and minus 2 respectively. Define dimensional formula and dimensional equation by using suitable example. Dimensional formula: the expression which shows how and which of the base quantity represent the dimension of a physical quantity. Dimensional formula of volume is in bracket m0 L cube T0 bracket over. Dimensional formula of speed or velocity is in bracket m0 L1 T minus 1 bracket over. Dimensional formula of acceleration is in bracket m0 L1 T minus 2 bracket over. Dimensional formula of density is in bracket m1 L minus 3 T0 bracket over. Dimensional equation: an equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of physical quantity. For example, volume V is equal to bracket m0 L3 T0 bracket over. Speed or velocity in bracket V is equal to bracket m0 L1 T minus 1 bracket over. Force bracket is equal to bracket m1 L1 T minus 2 bracket over. Density rho or in bracket D is equal to in another bracket m1 L minus 3 T0 bracket over. What is dimensional analysis? Question mark. State uses of dimension analysis. Dimensional analysis, a method of obtaining the solution of certain problems in physics by using dimensional formula is called dimensional analysis. Uses of dimensional analysis: first, to obtain the relation between the units of some physical quantity into two different system of units. Second, to check the dimensional consistency of equation connecting different physical quantities. Third, to derive the equation of physical quantity in terms of other related physical quantities. Obtain the relation between units of some physical quantity into two different system of unit. The unit of work in MK system is joule and that in CJ system is erg. The relation between joule and erg can be obtained as follows. Dimensional formula for work: W is equal to bracket M1 L2 T minus 2 in MK system, in CJ system. In MK system, M kg, L meter and T second is equal to 10 to the power 3 m gram is equal to 10 to the power 2 L centimeter is equal to 10 to the power 0 T second. Therefore, M1 L2 T minus 2 is equal to in bracket 10 raised to 3 m bracket over raised to 1, another bracket 10 raised to 2 L bracket over raised to 2, and third bracket 10 to the power 0 t raised to minus 2 is equal to 10 to the power 3 into 10 to the power 4 in bracket m1 L2 t minus 2 is equal to 10 to the power 7 in bracket m1 L2 t minus 2. So mk's unit of work is equal to 10 to the power 7 cgs unit of work. Therefore 1 joule is equal to 10 to the power 7 erg. Write and explain the principle of homogeneity. Magnitude of physical quantities having a same dimension can be added together or subtracted from one another. This principle is called principle of homogeneity of dimension. This rule is very useful to check the dimensional consistency of given equation. To check the dimensional consistency of given equation, all terms of both sides of the equation should have same dimension. Dimensional consistency do not guarantee correctness of equation. It is uncertain to the extent of dimensionless quantities or function. Heat produced in a current carrying conductor wire depends on current I, resistance R of the wire and time t for which current is passed. Using this fact, obtain the formula for heat energy. Suppose heat energy H proportional to I raised to A, R raised to B and T raised to C. Therefore, H is equal to K, I raised to A, R raised to B and T raised to C. Equation 1, where K is dimensionless constant, A, B, C belongs to R. Therefore, H is equal to in bracket M1 L2 T minus 2 I is equal to A in bracket capital A and R is equal to in bracket capital M1 L2 T minus 3 A raised to minus 2. These are the dimension of given physical quantity. Now writing the dimensional formula on both sides, in bracket M1 L2 T minus 2 bracket over is equal to in bracket A bracket over raised to A, another bracket M1 L2 T minus 3 A raised to minus 2 bracket over raised to B and bracket T bracket over raised to C. Therefore bracket M1 L2 T minus 2 bracket over is equal to bracket A bracket over raised to A minus 2B, another bracket M raised to B L raised to 2B T raised to C minus 3B bracket over. Equating the indices on both the side, A minus 2B is equal to 0, B is equal to 1, A minus 2 into 1 is equal to 0, therefore A is equal to 2, minus 3B plus C is equal to minus 2, therefore minus 3 plus C is equal to minus 2, therefore C is equal to minus 2 plus 3 is equal to 1, thus A is equal to 2, B is equal to 1 and C is equal to 1. Substituting these value in equation number 1, we get H is equal to K I square RT, but K is equal to 1, therefore H is equal to I square RT. Write limitation of dimensional analysis. First, in the dimensional equations containing capital M, capital L and capital T, we get at the best only three equations. By equating the indices of M, L and T, hence this method is of not useful in detecting the exact form of the physical relation which happen to depends upon more than three quantities. Second, the information about dimensionless constant cannot be obtained. Third, the equation containing exponential trigonometric function lie quite outside the preview of this method. And fourth, this method is of the no use if the constant of proportionality is not dimensionless. Consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that the period of oscillation of the simple pendulum depends on its length L, mass of the bob m, and acceleration due to gravity g. Derive the expression for its time period using method of dimensions. T proportional to L raised to A, G raised to B and M raised to C, where A, B, C belongs to Z. Therefore, T is equal to K, L raised to A, G raised to B and M raised to C. Equation 1, where K dimensionless constant. Considering dimension of both sides, we have in bracket M0 L0 T1 bracket over is equal to bracket L1 raised to bracket over raised to A bracket L1 T minus 2 bracket over raised to B bracket M1 bracket over raised to C is equal to bracket M raised to C into bracket L raised to A into bracket L raised to B minus 2B bracket over is equal to M raised to C into bracket L raised to A plus B T raised to minus 2B bracket over. Comparing power of M, C is equal to 0. Comparing power of L, A plus B is equal to 0. Comparing power of T, 2 minus 2B is equal to 1. Therefore, B is equal to minus 1 half. And from A plus B is equal to 0, A minus 1 by 2 is equal to 0. A is equal to 1 by 2. Put A is equal to 1 by 2, B is equal to minus 1 by 2, C is equal to 0 in equation number 1. Therefore, T is equal to K L raised to 1 half G raised to minus 1 half is equal to K in bracket L by G bracket over raised to 1 half. Therefore, T is equal to K under root L by G. Value of K is equal to 2 pi by the experiment. Therefore, T is equal to 2 pi under root L upon G. State the number of significant figures in the following: A 0.007 meter square, B 2.64 into 10 power 24 kg, C 0.2370 gram per centimeter cube, D 6.320 joule, E 6.032 Newton per meter square, F 0.000632 meter square. The answer is A, only one significant figure, that is 7, B 3 significant figure 2, 6, 4, C 4 significant figure 2, 3, 7, 0, D 4 significant figure 6, 3, 2, 0, E 4 significant figure 6, 0, 3, 2, and F 4 significant figure 6, 0, 3, 2. A calorie is the unit of heat or energy, and it equals about 4.2 joule, where 1 joule is equal to 1 kg meter square per second square. Suppose we employ a system of unit in which the unit of mass equal to alpha kg, comma, the unit of length equal to beta meter, the unit of time gamma second, so that a calorie has a magnitude 4.2 alpha raised to minus 1 beta raised to minus 1 gamma square in terms of new units. 1 calorie is equal to 4.2 joule, MKS system and new system. N1 is equal to 4.2 joule, M1 is equal to 1 kg, L1 is equal to 1 meter, T1 is equal to 1 second. In new system, N2 we have to find out M2 is equal to alpha kg, L2 is equal to beta meter and T2 is equal to gamma second. Dimensional formula of heat energy in bracket M1 L2 T minus 2 bracket over. Therefore, N2 is equal to N1 in bracket M1 upon M2 bracket over raised to 1, another bracket L1 upon L2 bracket over whole square, and third bracket T1 upon T2 bracket over raised to minus 2 is equal to 4.2 in bracket 1 upon alpha raised to 1, another bracket 1 upon beta raised to 2, and another bracket 1 upon gamma raised to minus 2 is equal to 4.2 alpha raised to minus 1, beta raised to minus 2, gamma raised to 2. Fill in the blanks by suitable conversion of unit. A 1 kilogram meter square second raised to minus 2 is equal to dash gram centimeter square second raised to minus 2. B 1 meter is equal to dash light year. C 3.0 meter per second square is equal to dash kilometer per hour square. D G is equal to 6.67 to 10 power minus 11 Newton meter square upon kg square is equal to dash centimeter cube second raised to minus 2 gram raised to minus 1. Answers are A 1 kg meter square per second square is equal to 1 into 10 power 3 gram into 100 centimeter bracket square second raised to minus 2 is equal to 1 into 10 power 3 into 10 power 4 gram centimeter square per second square is equal to 10 power 7 gram centimeter square per second square. D 1 light year is equal to 9.46 into 10 power 15 meter. 1 meter is equal to 1 upon 9.46 into 10 power 15 light year is equal to 1.057 into 10 power minus 16 light year. C 3 meter per second square is equal to 3 meter per second is equal to 3 into 10 power minus 3 kilometer upon 1 upon 3600 bracket whole square hour square is equal to 3 into 10 power minus 3 into 3600 bracket over square kilometer per hour square is equal to 38880 kilometer per hour square is equal to 3.888 into 10 power 4 is equal to 3.9 into 10 power 4 kilometer per hour square. D capital G is equal to 6.67 to 10 power minus 11 Newton meter square per kg square is equal to 6.67 to 10 power minus 11 kg meter per second square into meter square into kg raised to minus 2 is equal to 6.67 to 10 power minus 10 meter cube second raised to minus 2 kg raised to minus 1 is equal to 6.67 to 10 power minus 11 into bracket 10 square centimeter bracket over cube second raised to minus 2 into 10 power 3 gram in bracket raised to minus 1 is equal to 6.67 to 10 power minus 11 into 10 power 6 centimeter cube second raised to minus 1 into 10 power minus 2 gram inverse is equal to 6.67 to 10 power minus 8 centimeter cube gram inverse second raised to minus 2. The volume of the cube of side 1 centimeter equal to dash meter cube. Volume P is equal to 1 centimeter into 1 centimeter into 1 centimeter is equal to 1 centimeter cube. 1 centimeter is equal to 10 power minus 2 meter is equal to 10 power minus 2 raised to 3 meter cube is equal to 10 power minus 6 meter cube. The surface area of the solid cylinder of radius 2 cm and height 10 cm equal to dash millimeter square. Total surface area of the cylinder A is equal to 2 pi r in bracket r plus h bracket over r is equal to 2 cm is equal to 2 into 10 power 1 millimeter, h is equal to 10 cm is equal to 10 into 10 power 1 millimeter. Therefore A is equal to 2 into 3.14 into 20 into bracket 20 plus 100 bracket over millimeter square is equal to 1.072 millimeter square is equal to 1.5 into 10 power 4 millimeter square. A vehicle moving with a speed of 18 km per hour covers dash meter in 1 second. Speed V is equal to 18 km per hour. V is equal to 18 into 1000 upon 3600 is equal to 5 meter per second. 1 kilometer is equal to 1000 meter. 1 hour is equal to 3600 second. Distance x is equal to Vt is equal to V into 1 is equal to 5 meter. The relative density of the lead is 11.3. Its density is dash gram per centimeter cube or dash kilogram per meter cube. Relative density of the lead is equal to density of lead upon density of water. Density of the lead is equal to relative density of the lead into density of water is equal to 11.3 into 1 is equal to 11.3 gram per centimeter cube is equal to 11.3 into 10 to the power minus 3 upon 10 to the power minus 6 kilogram per meter cube is equal to 11.3 into 10 to the power 3 kilogram per meter cube is equal to 1.13 into 10 to the power 4 kilogram per meter cube.